Hey everyone, so we're about to take this study of rational functions and flip it in reverse. This time we want to write the equation. Before we had the equation, we did the graphs. Now we're going to be seeing a graph, and it's going to be asymptotes, and we're going to want to figure out what is the equation of it. So we're going to be working backwards from the graph to the equation. Now, I don't know if your notes have this particular slide in it, so you may want to write this down. It's kind of a guideline for you to think your way through taking the graph and writing the equation. But like when we did our graphs, we always factored. Well, that's how we're going to start. Start with the factored form. It's just that we don't know what the factors are, and we're going to be filling those factors in based on clues from the graph. So it's everything that we know, we're just working backwards. So another thing we know is the zeros relate to the top. So anything we know about zeros in the graph are going to tell us about linear factors in the top, or the numerators. Vertical asymptotes, everything we know about that goes to the bottom. And so we're going to use those big clues to help us write the equations. If there's a hole, that means there's a factor in the top and the bottom. Same factor. Now going back to the zeros, sometimes the zeros have bumps or chairs, particularly bumps. I don't think we're going to see too many chairs. We won't get any that are that hard. But if it has a bump, that means it is an even degree. So the linear factor might have to be squared. That's what's going to make a bump. The asymptote tails. Now I'm going to post in some examples in the playlist where the instructor is different. He doesn't talk about the tails, but he does talk about going down. So on the asymptotes, if we've got an asymptote going down, if the tails both go the same way, then the denominator may have an asymptote at 3. Let's make this -3. So since tails are both going the same way, it would have to be squared. But if you have tails where one goes up and the other goes down, opposite tails are going to be odd degree. So let's say this is 4. So x minus 4 would have to be 1 power. I'm just going, these are just rough ideas right now to kind of help you get started on this. The A number, we're going to have to find the A number by plugging in a point that we haven't used. That's going to be kind of a quick overview here of how you got to do this. So I'm going to do one example kind of quick, and then I'm going to... All right, so let's take on this example right here. It's a good idea to start a rational function. Actually, I should start with a different color. All right, let's take on this example. It's a good idea to start in factored form. That's how we started when we graphed. We would write down the factored form, and then we'd pull out the information we needed to do the graph. Well, now we're just doing it in reverse. So the first thing I'm going to do is observe the zeros. Now, if you recall, when we've plotted our zeros before, we focused on the top. So the zero information is going to give us information about the top of the graph, the top of the function, I mean the numerator. And so I have a 0 at -3, 0, and 1, 0. So the only way these zeros are going to come about is if something in the numerator will make y equal 0. Well, x plus 3 will equal 0 for y when x is -3. Same with this one. X minus 1 is going to equal 0 when x equals 1. So we were able to figure out the numerator by creating linear factors for each of the zeros. Well, the vertical asymptote also is a very strong clue for building the equation. The vertical asymptotes, as you recall, come from issues in the bottom. When the bottom is dividing by 0, the function is undefined. That makes a vertical asymptote. And we have a vertical asymptote at -2. So when x is -2, that's going to make something in the bottom equal 0. Well, x plus 2 will equal 0 when x is -2. Now that's it. I don't have any more vertical asymptotes. If there was another one over here, then we might be able to fill in another linear factor, but there isn't. We only have that one. Okay, but there's something else about the vertical asymptote, and that is the tails. So we would do this in 2 stages, if you remember when we graphed. In this graph, the tails are both the same. They're both going down. Now, if the degree is 1, if we have x plus 2, degree 1, those tails have to go in opposite directions. So we got to have one tail up and the other down. But that's not what our picture is providing for us. This graph has both tails going down. And the only way that can happen is if the degree is even. Now we're going to go with the simplest degree of 2, and that makes the tails go the same way. So in our denominator, we're going to have second power. That's our first step. We are more than halfway done creating this equation. All we need is the a, the stretch factor. And this is just like the polynomials. We had to set up the factors first. Second step, we had to solve for a. Same here. And I'm going to solve for a by plugging in a point. Now I'm looking over here, and here's a point I haven't used yet. 0 minus 3/2. So I'm going to switch it to fraction because it's going to be easier to solve my algebra here. So I'm going to take this and plug it into my equation here. So plugging in -3/2 for y. A, I don't know yet. I'm going to plug in 0 plus 3. And I'm going to plug in 0 minus 1. Now, I don't want to do all those zeros. I'm just going to do that in my head and simplify my work a little bit. So we're going to plug in 0 here. So we're going to have 3. Plug in 0 here, and we're going to have -1. And we're going to plug in 0 in the bottom. 0 plus 2 is 2 squared, which is 4. So -3/2 is equal to -3/4 times a. And now I want to get a by itself. Well, I'm going to multiply by -4/3 on both sides. And when I do that, things will cancel. The 3's cancel, the negatives cancel, and 4 cancels with that. So this is messy here. So I don't have much real estate. 2 equals, this completely cancels out a. So I just found the coefficient. So my equation is y equals 2 times x plus 3 times x minus 1 over x plus 2 quantity squared. That is the equation of that graph. And if I had doubts, if you have doubts, you can plug this into your graphing calculator and see that your equation makes the graph that you're given. That's one example. In the playlist, you'll see several more to help you get an idea. Do as many of those playlist examples as you need to so that you can do it by yourself. Study hard with this. Take care.